Let me start with a quick welcome to everyone. Welcome to Streaming Stories Volume 3. We launched this webinar series last month, and we are really enthused and encouraged by the participation and that we have received. And this is the third iteration. The first one was a product presentation. We introduced RisingWave, Apache Pulsar. Second was a panel discussion. Now we're back to, again, a product focused webinar. In this webinar, the title is How to Build Real-Time Applications Faster and Easier with Redpanda and RisingWave. That's a mouthful, but the goal is here to share our experience in terms of what are the challenges with building a real-time application and how Redpanda and RisingWave are kind of the new technologies that are in the data streaming space that are solving these problems. So I want to, again, first thank all the attendees for your interest in learning about this new space. This is a new emerging space. Looking forward to this presentation. From housekeeping items first, we're using Zoom for webinar, and I know some of you are already familiar with how Zoom webinar works, but just as a reminder, we have, the audio is only turned on for the presenters. We have muted the attendee line. If you have any questions, we encourage you to ask those questions. You can use the Q&A button at the bottom of your screen on the Zoom menu. Feel free to ask any questions. We'll answer them as the webinar goes. And in the end, we will try to keep a few minutes so that we can cover the question that we couldn't cover during the webinar. And then this webinar is being recorded, and we'll be emailing you with a link of the webinar as well as the slides. So you don't have to worry about taking screenshots or anything for the slides. And then the last thing, if you have any issues with Zoom, which we seem to have had with initially, but hopefully it goes glitch free. But in case if you have anything, feel free to contact the organizer using the chat button at the bottom of the Zoom menu. So I'll start with a quick intro. For myself, I'm Rayees Pasha. I head the product team at RisingWave Labs. My background is in the database management space and stream processing technologies. Prior to joining RisingWave Labs, I've held PM positions at Diagraph, Workday, Hitachi, and HP. And I started out as a database developer. Working on the system side. I worked on the database optimizer back almost 20 years back. And I've seen the database field evolve over time, right? Starting with the what used to be just relational databases to NoSQL with different data models coming in, and there's a lot of innovation. This field is one that is there's always churn and new innovation, new demands, new requirements that the customers bring, which is great for innovation. And in that cycle of innovation, we see streaming is a new way of how not just ingesting data, but processing, storing it, serving, which is kind of the new core problem I think the industry is facing. And RisingWave Labs is a company whose mission is to address that market. I have, from an education perspective, I have a master's in computer science from University of Memphis. Joining me on the webinar is Christina Lin. I would like Christina to introduce herself.
Hello, everyone. I'm Christina Lin. Yes, I am a developer advocate from Redpanda. So my kind of just going back to my past experience. So I don't look like it, but I have 20 years experience in the software industry. So I started as a Java programmer. And then that's how my first encounter with messaging systems. So I started when I was using MQ from IBM, and then I started to move into active MQs, and I joined Red Hat after that. So it was with JBoss, active MQs, and then I slowly moved into Kafka. And now I'm working with Redpanda because I do think Redpanda is a better alternative comparing to Kafka. And so that's why I kind of joined it. My background, I know a lot because I was in this integration space for a long time, so I can kind of talk about all the integration techniques and stuff that we do for the past 20 years. And of course, I'm very big in the camel space. And also, I know I've done a bunch of projects on Kubernetes and with automations on Ansible and all that kind of stuff. So these are the technology, my background. And yeah, so if you want to reach out to me, I have a Twitter account. You can follow my Twitter. You can we can connect on LinkedIn, whatever. Yeah, so that's basically about me.
Thank you, Christina. So let's look a quick look at the agenda for today. We're going to do things a bit differently. Typically, demos are the end. We decided to shake things a bit, and we'll start with a quick demo. Basically, we want to give a quick sneak peek at the products, both Redpanda and RisingWave. It'll be fairly high level just to give you an overview to see how the interfaces look like. And then I'll talk about the principal challenges that developers have to face when implementing real-time applications, right? Not in terms of the day-to-day challenges, but more in terms of what platforms to pick and why they should pick certain things. Because if you understand the challenges, then you pick the right tool, and from that, the journey becomes easy. And then the next phase, I want to talk a little bit about the solution and how streaming databases address those challenges. And then I want to focus on one key feature area because of limited time, we can go deep. So it'll be fairly high level. I want to cover a little bit about how cloud native storage is implemented in streaming databases. The second part of the presentation, Christina will talk about Redpanda architecture and how Redpanda platform is best suited for building real-time applications. So let's go to the demo. I want to just tee it up a little bit through just to give an overview. This is a obviously simple clickstream real-time analytics application. There is a ad capturing solution, like on a browser where the users are browsing and looking at shopping or reading articles. As the ads pop up, typically you have impressions of the ads, and then what level of how many users are clicking on those ads, what is the conversion rate from impression to click. That's what this application is trying to capture. So the data gets captured, gets sent to in real time to Redpanda, and then from Redpanda, it goes to RisingWave Labs. We create a data source, and in real time, we're able to give some insights into how the conversion rate is going on. So let's start with that. I will stop sharing for a second, and maybe I'll switch it. Let's switch over to Christina, and then she'll start, and then I'll come back to me.
Perfect. Thank you. I am going to go ahead and share my entire screen, my desktop. Is it possible for me to share my desktop? Can I share my desktop? Yes, I can. Perfect. All right. So what you are looking at right now is so just like what Rayees says about the application. So I'm going to start by streaming in simulations of the clicks. So what you're looking at right now is a very simple program that I wrote that is it's in Java Quarkus. So what it does, it's starting to simulate the click and the impression and starting streaming the events into my my Redpanda cluster. As you can see, the configuration itself is 100% the same as how you would interact with a Kafka cluster. So basically what you have to do is set up where the broker is. And then another thing that's really good about Redpanda is how secure we are. So we can set up SSLs, making sure that you have access to the clusters. And then that's how I'm going to start simulating data into it. So I'm just going to go ahead and start sending in clicks. And what is this going to do? It is going to then start simulating and start sending content into my cluster. So as you can see now, it's starting to send content. What is it going wrong? Yeah, all right, so here, now it's starting to sending content into my cluster. And if you look at the cluster, this is hopefully you can see that from here. This is our, make it bigger. So this is a quick cluster that I spin up on the cloud. This is already spin up on top of a AWS environment. And what you can see here is an overview of how many topics I have created in my cluster, and as well as, in this one, you can create numbers of topics, you can decide on how many petitions I want to have for my particular topics and the replications I want to have for that as well. So another thing that I have in this cluster setup is I have a sender and a consumer, which is from RisingWave, where it's going to start consuming my events. So what happens is I'm going to use this SASL to log into my topics. And if you look into the topic itself, you are going to start seeing the events start consuming into the topics. Why is it not showing? Let me see. Looking into it, so we're sending it to here. I am looking at, hold on. Am I sending it to the right place? Yeah, so I think it's going to take a while for me to kind of see the things happening in my cluster, but then it's going to start showing in my own. It's going to take a while to see things on here, but we'll come back to it. And then you can start seeing the data coming into the cluster, and the cluster will then be picked up by the RisingWave. Yes, so I'll probably turn this over to Rayees and kind of see things going on. And I'm going to stop sharing and let him share that.
Okay, thank you, Christina. So let me come back to my screen. I'm gonna share my browser session. So what you're seeing right now is the login page for our managed service called RisingWave Cloud. This is the beta version. So I'm gonna log in, and so you can sign up and get an account. In my case, I have an account. So this is the landing page or the dashboard of our managed service. Basically, what we list here is the general information on this page. We give you a sense of how many tenants you have, what plans are you under. Like I have a one tenant only running, and it's a free tier tenant, it's a small tenant, and then it shows that the status of the tenant is it stopped. So I'm gonna start the tenant now. So while the tenant is starting, and I'll give you a quick information. For each tenant, we give you all the information about what is the version of software that it's running, what region it's hosted, when it was created, what is the activity. Obviously, it's, I just started the tenant, there's no activity here. And what is the usage? And then we have some basic metrics that we show, like in terms of the CPU usage, memory, the throughput, that we are seeing in terms of the data coming in. And then the storage, like for example, this RisingWave is not just a stream processing engine, but it's also a storage engine, right? So how much data are we storing? And then the network throughput, that's also something that we're going to monitor. And then we also, like if you go to the tenants tab, if you have multiple tenants, you'll see different tenants, and you can also access this tenant specific information by clicking on the actual tenant. That'll give you, while the dashboard shows your activity across all the tenants, but if you want specific details about a particular tenant, you would go to this interface. And then in this particular tenant, and if you want to look at what objects have you created, you can create. And if you're created, in my case, I have not created any materialized views, so that's why it's blank. It also shows who are the users who are allowed to access data for that particular tenant. In this case, I've just created myself as a super user, and so there's only one user here. So let's log into the console. This is the interface through which users can run queries. So I'm going to quickly log in into the interface. So this is the console where you can run queries, run SQL queries. This is, and RisingWave is a Postgres compatible, standard ANSI SQL system. So any SQL that runs on a regular Postgres system would compile and work fine here. I have created some objects already, like for example, the one that Christina mentioned, the ad source topic with the data she's pumping. It's already a data source on my side as a consumer. It's already created, so it should be able to pick up the data that she's generating. I also have a couple of sample data set that I've created. Like, for example, there's a Twitter sample query that we have, and the data source, some of the information that we store in terms of what are the Twitter posts, who are the authors. Basically, this is a simple query to see what is the activity, what are the popular posts on Twitter at that time, right? So here's the simple one. I want to just rerun the query here. I've already created the source and I have the materialized view created. So I'm just going to run the query just to give you a sample of what the query interface would look like. So if I were to run, let me run the whole thing actually. Like if I run the materialize view, obviously that hashtag, that materialize already exists, so it gave me an error. But if I go here, if I run the query, I should get the rows back. So for example, when I run this is select star from heart hashtag. What are the most popular hashtags? Limit top 10. That's the query I ran. In this case, the results I see right here. The top 10 are, for some reason, there's a hashtag called multi, there's a 0, there is some sample synthetic data. And you can get the results instantly. And then if you go to the chart, you can do charting to draw the same information and see what is the, like, for example, in this particular query, we were mentioning the window within which these hashtags are being generated. And you can see when the window started, what is the most popular one and how many occurrences of that hashtag were there. And this is a query that you can set up here to run at whatever cadence you want, at a 1 second cadence, 5 second cadence, 10 second cadence. So if I set it up for 1 second, it'll keep running every second. For example, if you see here, every second it keeps running, so that if this data source was popping, Twitter data was popping constantly, this graph would automatically change, right? So that way you can, as a developer, you have the power to set how, as you do ad hoc analysis, you can see how often do you run and how the data output would change. So let's stop for a second here, and then let's go back to the job that this is the one that ad source that Christina had created. So let's
Rayees, I need to
yeah.
tell you, can you change so this is what is a live demo is all about. So we have things that's changed.
Okay.
So what happened was we have recreated the cluster. So now we have a different Bootstrap server name. So do you mind updating Bootstrap server name? I will paste that boot server name right now for you, so you can update it live.
Okay, let me do that. All right.
I'm gonna post that in the panel chat if you want. Just copy it to your to your Bootstrap server.
Okay. Yeah, I just copied.
It's exciting. This is all like live demo. So the reason why I'm not seeing the changes because we changed the server name was why. Do you want to drop that source again and then recreate it?
I'm just rename it to something new.
Okay, perfect.
That makes sense, right? So let me, keeping my fingers crossed.
What we're doing right here is establishing the connection between RisingWave and to our Redpanda cluster. So what you're looking at is creating that, establish that connection.
Yeah, I need to see if let me stop this guy because it's running every second.
Perfect.
So I'm gonna run this guy. Okay, there's some failure transport.
Okay, let's take a look at what's going on.
Like,
no, this is actually good. Let's take a look at what's going on.
Yeah. There is connector issue. Anyway, I know we are running out of time. I don't want to
do you mind like updating the username to RisingWave? Just do one more.
Okay, here.
Take out the consumer. Exactly. Yes.
Okay.
Let's do one last try. Because I have
one last try.
Yes.
Oh, okay. So
it worked.
This time it did work.
Exciting live demo.
Thank you. I'm sure. Thank you for being persistent because I was ready to bolt. Okay, I'm gonna run the query and see. Let's see what we get. Okay. So I got something. Hold on, the query is still run. Let me see. Okay, I got some. It's still not generating the data for some reason. Are you sure this is?
It should, but let's take a look at it later. We'll take a look at it later. But I think
I see 0 rows. So yeah, the connection is established for some reason. The data is not. Anyway, but I guess the general demo I wanted to show, now you see that just before I wrap up, you see the data populating in real time, showing you what is the cluster utilization and all that you can see here. So shameless plug before I end, if you are interested in trying our product, just this is if you go to our web homepage, there is a private preview link, and here you can get early access. Okay, that's the last thing. Let me switch back to the presentation. Okay. All right. So you guys can see my screen, right? Okay. So let's start with the presentation back, and I'm trying to make up time, so I want to be quick. So the challenges, like I said, the challenges are threefold for anybody trying to build real-time applications, right? So one, you have to pick the right data processing model, and data processing model is critical because traditionally you have batch as the incumbent. Like all the companies have their data stack built on traditional batch processing technologies, and this is kind of expected, right? You have legacy workloads that have really worked well. So the natural question is, why not use the same tool set for real-time stream processing? It makes sense, right? But the challenge is typical data processing in a batch works in a way where you have a series of distinct operations, right? Like and it's all user triggered. User goes and starts some job, and it's very ad hoc, and it uses the resources, and you expect that the full power of computation on the entire data set happens. But with real time, it's a little different. It's a continuous operation. You have chunks of data coming in, so you don't want to rerun computation on entire data set of what you have that you already have stored. You want to only focus on the new chunk that's coming in, and that's not possible with the batch processing model. And there's also other things like in terms of utilization of resources. There's other challenges that make it infeasible. Now the issue is, I'm not trying to make a broad criticism of the batch processing model. Batch processing has worked really well. There's so many pros. Like they're excellent when it comes to processing a workload that can be broken down into smaller stateless tasks. They're great at parallel execution, on creating, building, recovering from failures, on better load balancing. So all of these are great, but they're also drawbacks, right? They're inefficient when it comes to running iterative tasks, like for the kind that you see with real-time processing, where you have to do the same thing over and over again every second, as I showed in the demo. And because the underlying design assumption with batch is you have to have a scheduling overhead, you have to have coordination overhead for each batch, which is just too much cost for for continuous and for low latency processing, right? The second challenge is the infrastructure itself, right? Like traditionally, the infrastructure that's built for batch is built on-premise architecture. You have this data, your typical data pipeline looks like this, right? You have source systems that feed into a source database like OLTP database. You have a ETL process that kind of extracts the data, transforms loads, and then you put it in a data warehouse, and then the data is ready for serving, right? So it's like a pretty long latency driven model. And this kind of a model doesn't work for real-time applications. And the infrastructure for this kind of batch is very different from the one that you pick for real-time, right? So your new system has to be cloud native in the sense, because you really want to have independence in terms of how you can scale resources. And you should also, how you provision resources is also very different, because for batch model, you provision resources for peak throughput. In the case of real-time applications, the incoming data, there will be a lot of variation. Sometimes you have a burstiness in the application, so you could have a lot of data coming in, sometimes it's less. So how do you make sure that not only you address the performance aspect without under provisioning resources versus overutilization, where you end up spending money and not utilizing resources. So from that perspective, second challenge is the on-prem architecture versus the cloud native architecture. And then the third thing I want to quickly move to is the legacy system itself, right? Like, we know the batch processing doesn't work. How about the legacy streaming systems? Like, why not Spark streaming? Why not some other system? Now, the challenge with them is they were purpose built for specific workloads. Like, for example, with Spark streaming, it was for micro batch processing. And these systems were more complementary architectures to batch, right? So you have Apache Spark users, large community. So when they have some streaming workloads, you could use Spark streaming to do some data science use cases and things like that. But they were not purpose built natively to address streaming workloads. And in terms of the downside of that is they don't do the true real time. They do near real time. They do, like, you can shrink the micro batch window as small as possible, but you can never get to the point where it is discrete event, right? So they don't have the support for semantics that are required at for event-driven architectures. Now, I want to spend a couple of minutes on what I mean by event-driven architecture semantics, because this is very critical, because the words real-time, stream processing, they're overused, right? So they're like, there is real-time systems, streaming systems, which are focused on the micro batch side versus one that are like purely which allow you to actually inspect data at a granular level, at an event level. And how you do that is where your system can support certain data models, and which is what I want to talk about. There's a lot of attributes or characteristics to support that event data model, but I picked 4 here. One is event time. Like, for every event, the system should be able to discretely identify and treat it as a discrete unit in extreme granularity. If you don't do that, then you cannot really support real-time systems, right? So from an event time perspective, it's the time when the input event was generated in the source system. And then the second attribute is the processing time. Like, for every event, when the input data comes to the processing system, can we capture the timestamp so that we know exactly what the latency was? And the third one is the concept of watermark, right? Watermark is basically this threshold that you set so that even if your data, the streaming data, which can come in out of order, for example, the event time may be earlier, but the time, by the time it comes to processing, it might be later. Yeah. So in which case, to make sure that you are able to tolerate that out of order arrival and still be able to consistently process statefully. Like, for example, if you have stateful operators like aggregates, or if you are joining 2 streams and you're trying to identify what are the matching keys, you should be able to tolerate that level of out of order, or consistency issues. So your system should have that built into its architecture and data model, as opposed to forcing that burden on the developer. So the developer has to worry about matching these things, right? So those are the kind of things you need. And the last thing is the exactly once processing. This is a concept where, again, when the data comes in or out of order, or if there are duplicates, the system should be able to verify that it can provide some strong consistency guarantees. Now, this is critical for a real-time application, because if you're a developer, you're building a system, you're writing an application with the batch model, you have the recourse that you could reload the data and then address any data quality issue. With real-time streaming system, you don't have the luxury. You need the system itself to be smart enough to isolate duplicates or any other things to ensure that the consistency is maintained. And in the case of a streaming databases, the checkpointing mechanism that's implemented ensures that. That way, you don't have to worry about the data quality from that perspective. Okay. So we talked about the 3 challenges. Now, what does the solution look like? Obviously, the case I'm trying to make is the streaming databases address all 3 of these, challenges. One is support for event-driven architecture. 2, cloud-native infrastructure support to scale up and down. Third is being cost effective, right? Like which is and that's kind of a lot of these things. Fundamental principles are baked into how streaming databases have evolved, and that's why they're a new category unto themselves. Now, while the batch processing model was driven by user to input to pick up a job, in the case of event-driven processing, it's the event itself that will trigger for a job to get started, right? It's continuously running, and in some ways, what this streaming databases have brought is a paradigm shift where instead of instead of a user starting the job, it is pushing the database functionality upstream. As the data is in transit, we're able to address the pain points. So obviously, the event data processing model is more incremental computation driven, so that we don't do the full computation on all of the data, but just on the data that's coming in. And then that allows them to serve like ultra low latency queries at a very high concurrency, which is not possible with batch processing model. And obviously, we feel that's the best model to if you're building an application that requires continuous analytics, that's the best tool to pick. So the second factor is the one I talked about, cloud native architecture. Again, I don't want to repeat myself, but basically with our on-prem architecture, you had this really tightly coupled systems where you pretty much pick the infrastructure based on the requirements of the tool. In this case, with the new modern data stack, you really don't, you can repurpose infrastructure, cloud native architecture from one system to another, basically by decoupling compute and storage so that you can independently scale them. And then that way you can pick your compute footprint to mirror what the workload is. If the workload demands more, you increase the scale of the resources. If not, you shrink it. And also the scaling and scaling up and down needs to be elastic. That's not possible with on-prem because of the downtime and other issues. And the last thing on the challenges is the cost factor I mentioned. Like how if you adopt a new system, new technology, you don't want to incur a lot of cost because then it doesn't make sense, right? So there's three vectors there. One is the performance cost. Like for example, you could still do some of the real-time streaming or stream processing application with the batch, but the cost will be prohibitive for the simple reason that you're going to stand up larger and larger cluster because of the computation model. The full computation means for every job you have to stand up a lot more hardware than you would require with a incremental computation model. So that's one thing we get with streaming databases, the same performance but at lower cost. Second thing is the development cost, right? So one of the appeal for users to use traditional technologies is the familiarity. Like they speak SQL, they use ecosystem of tools that the developers are familiar with. In the case of streaming databases, especially RisingWave, we are SQL compatible. We use the same, we have Postgres wire compatibility, which means you don't have to learn anything new. You can come as you are, which means your developers are much easier. It's much easier transition for them coming from batch to real time. And then the last thing is the operational overhead, right? Like we are taking on this new technology. Do we need to have a separate stack for op manageability, for example, for upgrades, for other things? In this case, no, since we are cloud native, your existing tools in all of the major three clouds will be compatible with us. And there's no external software dependency. Like there's not some big data system where there's 10 different subsystems have to interoperate. It's one all-encompassing system, so that gives you low operations overhead, right? So just to recap again, what we have as a solution, the principal goal for RisingWave as a category, like our streaming database in general, they're designed to reduce the complexity and cost, right? Real-time applications have been something that are not new. They've been built by large companies who have the resources, who have the teams to build it. They're built using open source. They're built using their own resources. But they've not become mainstream for the simple reason that there hasn't been a tool that kind of encapsulates all these challenges, and which is what we are trying to address with RisingWave. Obviously, we use SQL as an interface. We are agnostic to upstream data sources. We can accept data from Kafka, Pulsar, Kinesis, Redpanda, you name it. Obviously, we have special connectors for some like Redpanda, and we're able to integrate much closely. But we are agnostic from that perspective, and it's not just the message queues, but also databases, file systems. We have dedicated CDC sources, so we can materialize source data into our system. And then, as I mentioned, since we do incremental computations, this is a great, a great way to do incremental computation, not just for the real time, but also if you want to do historical analysis. Since we are a data store, you can do both. So I want to stop here so that I give enough time for Christina to do her presentation. So let's switch over to Christina.
Perfect. I think I do kind of related to the SQL-based interface, because I think it's how data scientists works, right? So I was talking to one of our internal data scientists this morning, and he was going over how we're going to do analytics in Redpanda ourselves. And a lot of the work that, the data scientists were doing, tooling that are used are SQL. So, I mean, for them, it's like the easiest path to actually analyze the data, right? So I do think it's an awesome way of solving that problem, especially with incrementals and, live analytics. So just kind of go back to the basic of, how do we power these type of tools to enable you to do easy analytics, easy real-time analytics, and easy real-time processing. You need to have a very stable and resource-friendly type of backgrounds or backbones to do that. And normally people do that with Kafka, right? Kafka is a great way of streaming in data, because it's just because the amount of data we're getting these days is very much different from what we had 5 years ago, right? Like the burst of IoT devices and all that. Now we're having a lot more data we need to process. And so we need to have a better platform that can accept a larger bandwidth and can do a lot better throughput, right? So Redpanda is a different adoption, a different interpretation, different implementation of what Kafka is. So if you are a Kafka user, right? If you're connecting currently to Kafka, you can easily replace the platform underneath with Redpanda, because we're fully Kafka API compatible. So basically, whatever library you're using with Kafka, you don't have to change anything. All you need to do is just switch out the underlying platform, and it should just work. But it comes so with us, it comes a lot of benefits of switching to a Redpanda or choosing a Redpanda. The difference is basically for developers. I'm focusing this on pure developers because I know you all are users of Kafka. Or a streaming platform. So what we're looking at right now is if you're spinning up a Kafka environment as a developer, what do you need to do? You need to, first of all, spin up a broker. Oh no, you have to spin up a zookeeper first in order to get your broker running. And then you can run your application on top of it, right? So that's kind of a lot of things you need to do. So basically you need to run Kafka Zookeeper start, Kafka server starts, and then you have everything running in your local environment. For a developer, that's not so friendly because it takes time to do a lot of setups and all that. Now I know that there's a new version of Kafka where they're taking away Zookeeper. But the problem is, even with that version, you still need to configure a controller in order to control how your broker works, right? So as a developer, it's not that, easy, or it's not intuitive for you. So with Redpanda is you can pretty much spin up on its own. So basically just kind of serve on its own, and you can start writing or streaming data into the broker itself. And from the tooling perspective, there's a bunch of shell script you need to run with Kafka. So you need to know, you kind of have to start everything, and to create topics, you need to use different scripts to do that. But with Redpanda, you can start that with a single tooling called RPK, which is Redpanda Keeper. You can use that to start the container. You can use that to create topics. You can use that to produce messages. And we even have a console that which is the one that you just saw. So this console will allow you to see what's in the topic itself. So to kind of quickly show you, so that was the cluster that I was writing in. You can now see that the data are starting to go into the console, and you get to play with, like, look at what has sent into the topic itself, right? So you get to see a lot of things, and you can also filter, so for developer, this is a very debug friendly environment where, hey, if you want to say, I'm having errors, I do have errors, and it's probably coming from one of the events that's coming from my producers. I'm going to find out why, and say, if I want to look for, user ID is similar to that, I can quickly do a filter, and it's going to filter the ID that is related to this user, and I can quickly see what is going on with this particular event. So it's a lot easier for developers to find out what's going on inside the topic itself, right? And for people that is not so familiar with the streaming platform, when you create topics, you're asked to, enter a bunch of stuff, and it's just not that intuitive. So in the console, if you need help, there's a lot of help you can do. Say, if we're creating a new topics, you can kind of create everything on its default, but you also get to see the configuration here, and you can come back and change that. It is crucial for deciding on the policies of how big, how many consumer you're going to have for your topic, depending on if you can want to divide on different partitions, or how much longer do you want to keep your data in the streaming platform. So you can actually like deciding on how long you want to retain the data for. So these are the things that it's pretty cool for from a developer perspective. And there's a bunch of stuff that's a little bit different. So Rayees talks about, events-driven architecture. So event-driven architecture is awesome, but that also comes with a cost of what is actually in my topic, right? So I think a lot of people, when they're designing an event-driven architecture, the problem, if you want to have a very easy way of analyzing your data, you need to first think about what type of events you want to create. And by the type of events you want to create, you want to think about the domains, right? So that comes back all the way back to the design, the designing of microservices. In microservices, we have something called domain-driven design, right? So you want to make sure it's your microservices is grouped and retained within one domain, and everything will be serving for the domain. And the communication components between each microservices, we're switching from a more API-based into a streaming-based, so we can come back and analyze everything, right? So the designing of the things communicating in between different components your system is very important. And these are the events you want to design, right? So, but once you design your events, how do you make sure that people can discover these events? What kind of data shapes do you have? What kind of data format do you have, right? So that becomes very important. So schema registry is something that you probably want to use so that people understand what you're offering inside your event-driven architecture. And that is why you probably always want to set it up first. And Redpanda itself comes with schema registry. So you don't have to externally install schema registry outside of your broker. It's already contained in your broker, so you can set it up easily from a perspective. And I just want to quickly fly over this. The reason why I always want to bring this up is because if you think about what a streaming platform does, the streaming platform does nothing much other than putting the data into the disks, right? That's all it does. And the faster you can do it, the better. And the way that I think what we do better than the Kafka itself is that we don't have so much virtualizing layers. With Kafka, because it's written based on a JVM, it's inevitable that they have to do garbage collection. And garbage collection takes a lot of time, right, from analyzing it. But with Redpanda, because we're written in C++, we bypass all the virtualization stuff and the caching. We allocate a certain amount of memories, and we write straight into the disks. And that is why that makes us so much faster and so much easier to use. And the way that we use this core is very different, because if you think about computer systems, the cores are shared among applications, right? And they're very busy doing caching. They're switching to, okay, I'm going to do this application first. I'm switching to do that. That is how your computer architecture is set, right? But the way that Redpanda did it is we have this thread per core architecture where every single one of your core in your CPUs are allocated to do one thing, which is writing the data into memory and putting the memory and flushing the memory into your disks. And that's what it does. It doesn't share with your application, and we prefer you not to overload your system, of course. So it will drain the very much out of your hardware. So that is why a lot of developers, when they're choosing a testing platform, even when they're connecting to Kafka, they will use Redpanda as their testing case. So it's because it's just a lot faster and easier to start. And if you look at what we can do with real-time application processing to enable to ingest all this data, there's many different things we can do, like CDCs, right? Change data captures. So basically what you can do is we have connectors, or any of the VCM connectors you can quickly connect to all and listen to all the changes in your databases. And we can listen to all the events popping up from your services. And we can even ingest data coming from your edge devices through this MQTT protocol. You probably need a connector in front to actually accept MQTT, but then we can actually string things back into the broker itself. So just kind of, I really want to talk about this for developers. This is some things that I see a lot. So some of the best practices when you're trying to stream data. First of all, I see people kind of just ad hocly create the topics names, which is okay. But then when you have tens and hundreds of topics, how are you gonna let people that's trying to analyze your data, say if we've got, Rayees from RisingWave, he's trying to analyze our click streams. And if I name my thing not click stream, it's gonna say, I'm gonna create a name called topic A. How does he know what that is, right? So I wanna make sure you have a proper name, because in order to discover what it is, you wanna make sure your name have decide on your naming conventions. Maybe divide them into domains, and with domains, tell them that what kind of events this is. I'm taking a airport system here. So I wanna have flight domains, which I'm gonna push events on arrival, departures, and maybe plant problems. For passengers, I want to talk about check-in events, baggage events, upgrade events. So all these needs to be sorted so people can know where to pick it from. And like what I said, use the schema registry better, because schema registry actually tells people what is actually available in that particular topic, so they can utilize what it is. And because schema registry support versions, because there's no guarantee that you're going to change data shapes in your product. So right, so in the way that you're communicating, right? So you want to make sure that you're using the right versions, and if it's supported, right? So that's something that you probably want to think about. And another thing is the purpose of your topics. The reason why I'm talking about here is replications, because Kafkas or Redpandas, we use replications to make sure it's highly available. So if any problem crops up with the broker itself, I have the other brokers serving. So we want to make sure there's no data losses here, right? But the more replication you create, the more secure it is. The less likely you're going to lose your data. But then what happens is more internal traffics occur, right? Because when you have more replication, means that broker needs to talk to each other and replicate data, and that's going to take time, and it's going to cost you money. So if you think about it, so do I really want to have all the data available, or do I want to this is not a very sensitive data. I don't have to keep everything. Maybe I don't want to have all the replications. But Redpanda does a very good job of making sure you don't have data loss, but just in case. And another thing is retention strategy. Retention strategy, deciding on how long you want to keep your data in the broker itself. So with RisingWave, you can probably cache that and store that somewhere. So that's good. But what happens if you have a enormous spike in your throughput that could cause data loss because you can kind of just run out of space to write into your disks. So think about how long you want to keep your disks, how long you want to keep your data, and what are the retention strategy. Are you going to delete them afterwards? Are you going to compact them afterwards? These are some of the things you want to think about. Another thing is, can you take duplicate data? And then can you take duplicate content as well? So make sure if you're not allowing duplicate data, if you're not allowing, make sure you always do an idempotent producer with a specific unique ID assigned to your keys. So make sure you do that. And last but not least, secure. I see so many people does not secure their endpoints. It was just out there. People can write to the broker itself. So to me, that's not so okay. So make sure you always secure your endpoints. And that was about it. Thank you.
Great job, Christina. I want to add one thing to what you mentioned in the previous slide about the data retention. So I think one great strength that I would say for RisingWave is the fact that how we handle our storage. Like, for example, we have throttling mechanism so that we don't, if there's burstiness in the application, there's a lot of data coming in. The developers or the admins have tools to store data in tiered storage. Like they can push the older data. So we have 4 different layers of storage, and they can also devise strategies of how aggressively they want to do compaction, so that you don't have a lot of fragmentation in the data. So those are some of the things I didn't, obviously we can't cover everything, but that's one critical aspect that you raised, and I think streaming database, like especially RisingWave, can handle that as well.
Definitely.
So I think we have a couple of minutes left, and let me quickly see questions. So one question I got, and I want to address this. Like how do you, by you I mean I think the questioner asked RisingWave compare against vendors like Materialize, who are also Postgres based. Excellent question. I think Materialize is a question we get a lot, right? Materialize also, they're a bit farther along in the journey. They've been around longer than us. They have the similar functionality in terms of they are Postgres compatible, they are SQL based. Now, the principal difference I would say is how the systems have been built. In our case, in RisingWave, we started from scratch. We are cloud native. We're distributed by design, and so in some sense, when it comes to scale, when it comes to handling larger workloads, we believe we are definitely, we have the platform in place, and then we build things on top. With Materialize, from what I can tell, they were focused on single server architecture and more processing as opposed to processing and storage. They're trying to add other things now, but I always notice that it is the big things, the first principles, so to speak, like in the engine, the platform. Those are things you don't want to do revisions later. And I think that's the principal change, I would say, but I don't want to, obviously, it's for developers to evaluate the tools side by side and see how they see each one. I see another question: can RisingWave be used as a time series DB like in Flux? Sure, we do have some functions, but our for time series functions in our library. Now, from a data model perspective, if you have a pure time series application, there may be things missing, obviously, because we are not purpose built for time series data. But you could, if it's especially real time and quick ultra low latency, we can definitely address use cases. Please get in touch with us. We're happy to understand and see if there's anything lacking in our product. We're happy to add to that. Any other questions? Can it run self-hosted? I think that's another question. Yeah, I think I'll let Christina also chime in. First, I'll go. Yeah, RisingWave is an open source project as well. We are a managed service and an open source. So we have a Kubernetes operator. So if you want to host yourself on custom hardware as opposed to public cloud infrastructure, that's fine. We're happy to provide community support, but as a commercial offering, we're only available on public cloud infrastructure. Krishna, you wanna
Sure. Of
yeah,
course. So
if you have the
Redpanda,
same, yeah.
with Redpanda, you can self-host it on the cloud. So we do have another offering called Bring Your Own Cloud. So that's for people that doesn't have a doesn't want to do infrastructure management where you have a smaller SRE teams, but you also have problems with data sovereignties where you because there's some regulations where they're required to keep your data in a local environment that you cannot, there's a problem with geolocations or whatever, we can help you manage the infrastructure. So basically what we do is we'll deploy that cluster for you into your own cloud, and we'll use a separate agent to help automating the help of making sure we're managing your infrastructure. But we have no visibilities into the data whatsoever. So that is another way of doing it. For the developer's sake, we have partnership with other companies where we can do taste containers, where you can bring up Redpanda in the small containers, or you can just install it on your desktop, whatever. But it's all available, and we also support installations on Kubernetes as well.
Thank you. There's one more question for you, Christina. Can you estimate the speed of how much faster Redpanda is over Kafka?
Yeah, currently we're saying 10 times much as throughput, and there's a better, I can send you a TCO report right after this, but there's a better latencies as well. I think it's the way that we built around our replications, where it's, in our case, it's a lot faster to respond.
Okay. All right. Any other questions, guys? Okay. If not, I think thank you so much. I know we had some hiccups getting started. Thanks for being patient with us, and we appreciate that you guys joined, and hope you learned something from it. And feel free to reach out to me or Christina, and if you have any further questions. We'll be sending a link and the slides soon. And please do share our feedback overall in general about streaming stories. You like the format, and what topics would you like us to cover in future? Everything. This is a community driven initiative, so we want to hear from you. Okay. Thank you. Have a good day.